Hi, my name's Michael Crawford. I'm your training instructor for this demonstration. Today we're going to cover basic modeling principles. So the first thing that we're going to look at is how the assembly models are related to one another. Assemblies and mates, then attachment sketches, and then the top-down driving approach. We'll look at relationships, parametric behavior, driving sketch component creation, and then envelopes. I think that should pretty much cover all the basic modeling processes. Connections are another demonstration video, training video. This is to teach you the basics and understand at what level where items should go and why they are there and how we can control the process of modifying them when we need to. Okay, so get us started. I've created a project in the previous project, previous tutorial, and I'm going to open that up in one of the zones. So if you remember back, I actually inserted a section. I'm going to remove that section, and I'm going to show you the difference between inserting sections, inserting models, what happens with the file naming, and how those items are connected to one or the other. Okay. So first things first, let's just simply clean this out. So we've got a part. You can see this is a part. We're going to delete a part. Don't just go in and select the part and hit delete, because that will just delete the file out of SolidWorks, but there are still files in the filing system and you have to go and then clean them out. What this does is both in the same process, and then backs it up and puts it into our deleted files folder, so that if you accidentally delete something, you can come back and get it and drag it back in and mate it. I'm going to cover that process right now so that you can see what automation is being applied through using the Steel Designer Pro application. So first of all, we've got these menus at the top for each item for insertion from our libraries. So our libraries are our key process for us to develop and model our projects faster than any application on the planet. SolidWorks itself lends a very basic process for inserting items into its libraries by drag and drop out of Explorer into the window. We don't actually do that. We use our libraries via our interface at the top in the command manager, or via our toolbars, which you can right mouse click and see our toolbars here. Most of the time we just use this command manager to insert the items. So we've broken it up so that you can see that our tasks are spread across multiple task manager tabs, and they all have a particular role, and they all are and can be used in different assembly levels. At the moment, I'm currently residing in a zonal level assembly, and in there I have a driving sketch component. Driving sketch components can be added from scratch and then drawn in as we go. So what I'm going to do is, driving sketches don't have a solid, so you cannot select it and delete it using our parts delete method. So I'm just going to delete it out so that it's gone completely. Hit Control Q, Control S, and then open up the folder and then delete it from here, so it's gone. Now we have no driving sketch to attach to. If we want to put in a new driving sketch, it is a part, so it's a driving sketch component, and we want to start from scratch. So we can start from scratch by simply going to our parts command manager and then going new to add a new part. Make sure that we've got driving sketches selected, and then in here we can go blank, and up comes the blank. To make a driving sketch non-existent or not excluded from, to be excluded from the bill of materials, we need to insert it as an envelope, and I'm going to insert it at the origin. And I'm going to hit my tick and I'm going to insert it. You can see automatically it's put in the next component from the library as a blank item. There's nothing inside of it, and you'll notice because I've deleted the first instance of driving sketch 1, it's now jumped to driving sketch 2 automatically, even though 1 was in there before. If I wanted to reset that instance, I'd just get out of the assembly, get back in the assembly, and then insert the new item, and then that'll kick off as 1. It doesn't matter in our filing system whether that's 1, 2, or whatever it is. It doesn't mean anything to us. It might mean something to you if you need to reset. So that's how it's done. Okay, so now we've put in a driving sketch. What I'm going to do is show you how we attach and drive a driving sketch. So if we go down to the driving sketch level, and on the top plane we're going to put in a sketch, and you'll notice the sketch direction is very important. So if I go over and select under the sketch line and draw from the origin, now if I can't snap onto anything, it means that I've turned off my snaps and I need to turn my snaps back on. Just be mindful that that can happen sometimes while you're working. I've turned them off, so I want to turn them back on again. There is a shortcut key, but this is the way you get to them without the shortcut key. So if you go to the sketch relations and snaps, enable snapping, and that'll turn it back on again. Click OK, and now when we go back to sketch, select the sketch segment, it should snap to your origin. I usually always start at the origin with my sketch segments or sketch drawing process, because then that locks it as I go around. So I'm just going to draw a basic rectangle, and you'll notice that I've drawn a rectangle rather than selecting rectangle. Now the reason I've done that is because you'll notice that my sketch direction started from there to the right, to the top or rear, to the left, and then back to the front. The sketch direction is important. However, if you do manage to stick something in the wrong direction, you can switch and reverse mates under our tools. But it's always good practice to always draw from left to right, anti-clockwise, and draw any columns or any items that are on a slope from bottom to top. In this case, I'm on the front plane, so everything is left, right, rear, front in its directions. Now I'm going to add dimensions to lock this in place. Now this project is, I think, from memory, it is in millimeters per kilograms per second, so I might make that 6 meters and make this one, I'll zoom out, make that 4 meters, and then save my sketch. Good practice to always name a sketch, so base sketch or sketch, some kind of name that everyone can relate to, because when you double click on something, you want to be able to change it fairly quickly by changing it simply by double clicking on the dimension and then changing it parametrically. So this is going to be our driving sketch to kick us off. I'm just going to show you how the Steel Designer Pro attaches to driving sketches with sections and welded members. So first of all, we have a sketch in place. I've closed off my driving sketch and I've gone back to my zone assembly. Now zone assemblies can take welded members and parts and connections. We can insert connections at zone level assembly level as well as project level assembly level. In this particular case, I'm not going to cover connections. That's in the next video or one of the next videos. So first of all, let's go through the process of selecting something from the library and inserting it. If you've tried our trial, you'll see that this happens automatically from the library. So here I am picking a beam. The beam is automatically set down. I select it, click use, and then attach it to a sketch segment. I can select as an insert on sketch, which will put it on every single one of these and create a new welded member for each one. In this case, I'm only going to insert it on this sketch segment. Now when I say insert it on this sketch segment, there's a few things that have occurred for that to happen. So let's go through the process and break it so that what's in it starts from scratch. So at the moment, we have not connected this member to anything. Right? And inside of it, it uses mates to lock it into place, and it uses a relationship to a sketch segment that we put inside that drives it. We've also done the same thing with the section component in underneath that as well. So welded members are an assembly that contain sections that are welded together. Usually we'll start off with a welded member with one section in it, and then we'll start adding more and more sections. to make it welded, or we'll add plates to make it welded to the plates. So this is sort of like a very basic kick-off member for us to be able to utilize and add more and more to. At the moment, it's mated in place with these mates and it's related to the sketch. The same thing applies with our welded member with the section. So let's click on the welded member and open it up. Now we can see at the welded member level what's involved. The same thing applies. We've got mates and then we have a section. An attachment sketch which is related to the attachment sketch in the welded member from the section, and then back up the tree to the Zone Assemblies driving sketch. So if we wanted to see how all this works, let's pull it all apart and do it all manually so that you can see how this process works. Manually will give you a better insight as to some of the automation, or actually all of the automation that occurs when we select an item from the library and attach it to a sketch segment or to a sketch or a series of sketch segments that we've selected. So let's go through the process. Welded member, we want to delete it, its files, its folder and everything as well. So we click on delete. We're going to delete it and it's gone. Backed up in our deleted files backup folder. Okay. Now, to start this off, we're going to put in a blank member. So up here, we want to go new. We're going to go beams, select a blank member. Select use, and we're going to insert it at the origin and not related to anything. Now, if we were to do this, we would have these files off to the side in the normal context of SolidWorks, and we would have to use a pack and go to rename them, and then we would create a folder and then insert them into the project by copying the folder over. In this particular case, the automation has created the folder, it's brought across the blank member, the drawing, and its driving sketch. If we need a driving sketch, we may not need a driving sketch. In this instance, we're not going to need one, so we can actually remove it from the beam. Now, if you delete it, it won't go because it's loaded in the model. So we need to remove it. Go back, select the driving sketch and delete it. Delete only the selected component and hit Control Q to let SolidWorks release it, and then Control Save, Control S for save, and now we can go into the beam and delete that driving sketch. It's gone, it's been released. Now we only deleted it because there's nothing in it, and it's gone. So now what we're going to do is, in that beam which is now floating, we don't know where it is, we can't see it, but if we select the origin, we can see the origin is at the origin of the assembly that we've selected. Now if I click float and select it, select assembly and then move, and just move it away, when I start my process you'll see what's happening. Under the welded member we have an attachment sketch. Now that attachment sketch is automatically added because we've already put it inside of our welded members blank setup. So I'm just going to remove it so it's gone. So now we have the welded member, if we open it up, with nothing in it except our data link. I'll get into data links later. Okay, we're not ready for that yet, but I will cover them very shortly in the next video. So let's kick off a sketch on the top plane. Now all of our driving sketches for anything can be drawn on top plane, front plane, right plane inside of our welded member. So an attachment sketch is a sketch that's going to attach to another sketch. Our attachment sketches are important. They drive everything, and usually for our attachment sketches, right, inside of assemblies are drawn in the same direction to the driving sketch segment that we're going to attach to. Because this is a beam, all of our beams are drawn on the top plane from left to right, and we always start at the origin. So in this case I'm looking down in plan view. I've moved to plan view on top, and I'm going to draw my sketch segment from left to right. What we want to do is, this has to be the first and the only sketch segment. So if I accidentally delete this and put another one in, it's going to give it a new counter. So just be mindful that when you select this sketch segment, that there's a counter. And to find out what that counter is, if you've got your tools enabled, so if you right mouse click, click tools, and you select the measure tool, and you select the sketch segment, but you can't do it, sorry, until you're out of the sketch. Select the sketch segment, select the measure tool, and you'll see line 1. Now if it says line 2, line 3, line 4, you need to delete the sketch and start again. It must be line 1 in order for this to work. So I'm going to go back in, edit the sketch. I'm going to give this thing I'll make it 3 meters long. Save my sketch, and by the way, my snaps are on. It's automatically set a horizontal line from left to right on the top plane. Now I've created my sketch. I need to name it attachment sketch. The naming AS is important for it so that it can be attached via that sketch with a relationship between the sketch segment at this level and the driving sketch above that we've selected. Now that we have this attachment sketch in place, we can create more sketches if we want to at this level. This is a welded member assembly, which means that it can be a beam with cleats attached, or it can be a frame, it can be a ladder, it can be anything that is welded together, even a tank. So in this particular case, I'm going to add more sketches to this attachment sketch to show you how I would create a platform that can be driven. So I'm going to draw my sketch as usual from left to right around in a square. And if you're not familiar with SolidWorks in 3D space and the yellow lines as they come up, you can put it back in plan and then snap your sketch. But what you'll find is sometimes it does not attach. You have to attach it on the endpoint in 3D space. Now I'm going to give this platform a width of 1200, and now I have another sketch to which I can attach sections to. So what I'm going to do now is I'm just going to rename that sketch feature to master sketch, capitals. And what this does, sketch, got a bit of fat fingers going. So master sketch is going to let me know that there are items to be attached to that master sketch, which drives everything. Usually once I've created my attachment sketch, I hide it so that it can't be seen. And then by doing that, then I need to go through and add another sketch segment if I want to add another item to it. So I've just edited that sketch and now I've saved it. So now I'm not attaching to my attachment sketch, I'm attaching to my master sketch. And the reason I do that is because just say I wanted to offset my master sketch, I can by putting a dimension on this sketch segment and attaching it to the attachment sketch and making it offset. So it gives you a little bit more flexibility. Now if I wanted to attach components to this item, I then would have to normally grab a part, pack and go it, save it into this folder for the driving sketch, for the welded member, and put it in here. And I would have to name it something that would make sense. But because we've got automation, we don't have to worry about that. Usually it's a pack and go process, but in this particular case I'm going to show you how you can put a section in without attaching it, and then I'll show you how it's attached. Okay, so we're going to put in a new part, a brand new part. So a new part goes in and we're going to select section. So we're going to put in a new section from scratch. So we go blank. This one is going to be inserted at origin because I'm going to show you how it gets attached. So the section has been added and it's been named. Usually you would have to pack and go that. Playing around with pack and go can take time, right? Sometimes there may be a drawing. In this case there's no drawing, so we'll have to create a drawing for it. That's the reason why we insert sections from our sections library rather than creating from new, because there's a drawing behind it. But I'm going to show you how this works from scratch. So in this case we've got our section, and inside of our section there already is an attachment sketch similar to what we did with the assembly. I'm just going to turn that on so that we can see it. Sorry, show it, not edit it. And now I'm going to add a welded member to it. You'll notice my welded members are not turned on, so I'm going to turn on my weldments. Click on weldments, I'm going to select structural member, and in this case I'm just going to select, because I'm in Australia, any other country. PFC is a parallel flange channel, or a channel for those that don't know. So I'm going to select the sketch segment as you would normally do with SolidWorks, and now I'm going to select its location profile and set it down. Now we've got ourselves a section. We have a Steel Designer data link in here. I will tell you what that's all about very shortly, but for now, if I hit Control Q and Control S, that saves that part. We don't have a drawing for it, so now I'm going to create a drawing. So you go open drawing, and you can see that there's no drawing, so we're going to create a new one. So if you go up into new, my sheet templates have not been set up properly in order for me to collect them. However, I'm just going to grab a drawing and go from scratch, browse. Now I'm in a project, so I'm more than likely going to use the project's sheet templates. This is a section, so I'm going to use my project sheet template for a section. Now I'm going to drop my section onto the drawing. All of our drawings, every single one of them except for GAs, we have one-to-one relationships. That means that whatever I've put on this drawing is the only item that's related to the drawing, and it has the same name. What that means is the section that's automatically up the top here for this sheet is identical to the section that I've added. The same goes for plates, and the same goes for welded members. So if I turn this around, set the drawing up, create my views on my drawing sheet, select hidden, right mouse click, turn off the tangent edges. Just got to make sure you do it for all of them. I should have done that before I created my views. And I like to do it on the ends as well, just in case. I go and put a dimension on it, and you'll notice that my drafting standard is not right, so I'm going to set my drafting standard. If I go to Options, Document, Properties, Load from External File, go to my library, go to the Australian one because I'm Australian, I'm using Australian Library, and then go to Drafting Standards, and weldment and section and vendor drawings are similar, so I'm just going to use that one. So now I have my section. I'm a stickler for center lines because this makes it symmetric. I like putting center lines on items. And now I've got my model. This will stretch based on the origin's location, so I need to set it up so that the origin is at the left hand corner, which it is. So this could stretch to the right, and the scale may end up changing a fair bit depending on the length of my platform. So you might want to just make a rough estimate of how the scale should be. I've just hit Control and Control Q and Control S, and by default, because it is the section that's in it, it's automatically picked up the name of the section. So I've just clicked Save. I want to change the scale to something a little bit less, okay, because this is going to grow, and I'm pretty sure it will grow to about 6 meters, and 6 meters on a 1 to 10 drawing sheet should work okay. Might be a bit tight, but we'll see how we go. So there we go, there's that. Now I'm going to remove this border. I don't like the border that SolidWorks supplies us. It's gone. Save. There's the sheet for that section that's been added. Now the section itself is going to be floated, so we right mouse click, float, and move it. I'm going to show you what automation is applied when we insert the section into our project. So if you select the item, click on the origin, click on the start point of a sketch segment, and this sketch segment we know goes from left to right, so the start point must go from that end to that end. If you're not sure which one it is, if you edit the sketch and go into the sketch, there's an additional parameters pull down which will show you a 0, minus 1200, 3 meters, minus 1200. So when you're looking at a sketch in 2D, it's X and Y only. So X is obviously from left to right, and Y is if X is to the right, sorry, or left and right, and Y is up and down. So in this particular case, you can see that the Y values are identical, and you can see that the lesser of the two X's is the start point. So that's definitely on origin. So we know that this is the start point, and we know that that's the end point. Exit out of the sketch. So we select the origin, we select the sketch segment point, and we attach it by creating a mate. I'll do that again. So the next step is you've got the sketch segment on the end. You can just see me select it now, and then I select the sketch segment, and then I add a coincident mate. On the top plane and the top plane, I'm going to add an angle mate and make that 0 and hit my tick. So now this is fully defined. I can't move it. You can see down here on the right hand side, fully defined is gone. There's one more step. This has mated it in place. Now we need to make it so that it stretches the length of the sketch segment. We select the sketch. Actually, I'll go back to what I did. I selected the sketch, edited the sketch segment, selected the sketch segment that's in the active sketch that we're working on, and now I've selected the driving sketch that's in the welded member, or the master sketch in the welded member, and now I'm going to make them have an equal relationship. Okay, now you'll find that having an equal relationship will allow us to turn this around if we need to via our tools, reverse mates. If you attach it from the sketch endpoint and to the master sketch endpoint of that sketch segment, you will not be able to use reverse mates, because what will happen is it'll fall over. It will try and stick the origin on the endpoint, and it'll make it a 0 length line, and it will fall over. So always make it equal. But anyway, Steel Designer Pro does this for us automatically. So everything that we've just gone through is automatic when I go to insert something from the library. So we don't have to worry about any of these things. Now you can see the benefits of using such a product that we offer. Now, this item has been modeled up and it's missing some key component data that should be in it. I will cover the data that needs to be in it in one of the next videos coming up. I'm going to delete this one, and I'm going to insert items from the library so that we get all the drawings, we get all the sections, and we get all the mates and all the relationships happening all in one go and fully automated, so that we can just sit back and get ready for a trim. Okay, so let's delete that item out. So this goes, our work that we just did is gone, removed. Now I hit Control S, sections. Select a section from the library. I happen to have a PFC in the library. I'm going to select the sketch to insert it on. Select OK. Now all these items aren't going to be set down via the location point, and they're not going to be orientated the way that I would normally do these. If we go to Tools, we can go Reverse Mates, select the sketch segment, click OK, and that'll turn it around. And all that's done is it's just shifted the mates. Do the same thing for this one. Same thing for this one. You can see it just in that image then that it did it. And same with that one. Now what I'm going to do is I'm going to select it and modify the section. So straight up you can see that it's picked it from the center. I'm then going to select all my other items that are in my welded members, and for some reason, there we go. I'm going to select the top left hand corner and hit my tick. Now this will go through and it will move all those items down so that the top is back. Now you can see that that shifted them all. Hit Control Q, Control S, so that the heel is at the back. But I don't really want to do that. I want to change it so that they're all at the front, so I can get, rather than having an extended mitre on my platform, I'm going to set two back so that they're on the inside, or set all of them back and then trim them all, or mitre them. So to do that, I'm going to do one of them, and that one is just to bring them all back so that the position of these items are at the top toe of the channel. So if we click and then select Modify Section, and you can see now the point at which the section is attached is now at that point. So I'm just going to go and change all these to be at the top right and hit my tick. You can see now I have all my sections overlapping one another. I can choose to either miter them or trim them. In this case, I'm just going to trim them. Mitering involves a bit more work because of the butt welds having to be ground flush or even prepped. So it's just less work for me just to butt two channels together using a trim process. So I'm just going to use the trim part process, where you click on trim part under tools, select the part that's going to be trimmed and the face it's going to be trimmed against, and hit the tick. I'm going to do the same thing at this end. Trim again, the part that's going to be trimmed and the face is going to be trimmed against, and also hit at the other end. So what's happened with the trims, so that you're aware of the trim process. So when I open up the component that was trimmed, you'll notice that there are two planes. These planes are related to the faces that I selected, and then two trims have been applied to the section. Why do we do this? It's simply because when you trim a component against a face, you do a rebuild at the assembly level above, the trim can fall over. By putting a plane in, the rebuild process of the trim occurs against the plane that resides in the same component, and it's much more stable. It does not fall over. And the automatic process of trimming does that for us, so we don't need to worry about that process and the time it takes to do that process. Now, our attachment sketch, I've forgotten to do this. You should always grab your attachment sketch and drag it up to the top, because everything is top-down driven in SolidWorks. Okay, so now that's been added to the top, and all the components are hanging off that item, so that when it rebuilds, it will rebuild down the tree. All these items are now attached to my sketch, so that when I change my master sketch, which is what I'm also going to drag up as well, and just be mindful that sometimes you get a little bit of delay. I'm just waiting for it to, yep, okay. I can't select anything. Sometimes SolidWorks does that to me. I'm not exactly sure why, but I will get back to it. The only way to solve this problem is to get out of SolidWorks and get back in again, and then drag my master sketch up above as well. I can't close SolidWorks, so I'm going to have to kill it. It affected the whole process and anything that I need to select, yet it's funny, I can select items. I can't select escape. Control Q, Control S does nothing. It won't let me select anything, so I've got to kill SolidWorks. One of those little fortunate processes that can cause grief. Should I say unfortunate processes? So we go back into that zone level. It's the default configuration. Open up the beam that we're working on and shift the master sketch up to the top, and we might get the same thing happening again. If we hit Control Q, Control S, nope, we're good this time, so we don't have to worry about having to kill SolidWorks. And see how it's intermittent? Don't know what causes it. But anyway, now if I was to change my master sketch in any shape or form, my sections are related to that master sketch and they automatically update, which is pretty cool because SolidWorks is really good at doing that. Also, for all the 4 items that I inserted into my project, I have drawings behind them because it's come from the library. As you can see, that automatically updated in its length. And the same with that one. You just tidy it up a little bit, move things around. Okay. I could duplicate that part over to there, and I can duplicate that part over to there, but because we've got consolidation, duplicating may not be the solution because you may need to make a change that could require putting a hole into something, putting hand railing on one side that is different to the other side. So sometimes it's always best to create these items as singular items. Okay, now on our platform we've also got a welded member drawing that we need to update as well. So we go into the welded member and we can Control Q, Control S. Now the welded member itself is fairly basic in its process. There's no tags or anything in there. We can come back later and create a welded member drawing for this that will put the tags all over it, and it'll put a label in for us and a bill of materials. So we will do that later. But for now, this is a basic modeling process. We now have an attachment sketch that will stretch this along this length. We also have a master sketch which will allow us to double click on it and change its length. Now I could attach another attachment sketch. I could draw another attachment sketch in here which sets up the width of the platform as well. So we can do multiple attachment sketches when we insert our item from the library. So this platform itself is pretty basic in its own right. I could put angles and other channels in it to stiffen it all up, but I just wanted to show you the basics of how we can model something fairly quickly. Now we're at this assembly level, which is the welded member level. I've just closed it off and now we're at the zone level. So it means now we've got this welded member and we've got an attachment sketch. So I'm going to attach that attachment sketch by clicking on the sketch segment and editing the sketch feature. I should say, let's go back and do that again. Edit the sketch feature in context, select the sketch segment, select the driving sketch segment underneath and make them equal like we did before. And you'll notice the platform now has updated its length. Now watch what happens, because now I've built this thing and I've put all this work into it. I can upload this to the library and reuse it by uploading it. Now I can also use the project as a library itself. Here's a simple explanation. If I go copy, select a section in the welded member, select the edges that sketch segments I should say, that I'm going to attach it to, and then I'm going to hit my tick and watch what happens. Now that's pretty quick. That's pretty cool. So what's happened here is it's attached all the sketch segment, all the welded members attachment sketches one by one. There's that attachment sketch, there's that attachment sketch, and there's that attachment sketch, all attached, all the mates in place. So it's used the same welded frame at that level for all the others. So if I was to go and open up the second attachment sketch, the second welded member, you'll see that that one's automatically updated and has been adjusted. Before I copy my welded members, I should have made sure that my welded member drawing was ready for me to duplicate. Otherwise, I've got to go back through my welded member drawings and update them. So you want to make sure that they are actually spot on before we even duplicate. If that's a problem and you've done that, but you haven't put much work into it, you can actually go back and delete your welded members and do it again. So all I'm doing is just selecting sections that belong to each welded member, and now those welded members are gone. Let's have a look at what's happened to our welded member as it was created. If we go and open up the folder for the welded member, you can see that this is what it was called when I inserted it as a beam. I did not select insert blank frame, I inserted it as a beam, and in there you can see that I've got the drawing, I've got all the sections, and all the section drawings automatically set up for me. That's a lot of work saved. Okay, so now what this does now is this allows us to be able to go open up the drawing. We'll make sure that this is set properly so we've got some dimensions on it, and we'll even add some tags so that we know what we've got here. So I'm just going to go and do the basics. Okay, you can see here now, if you've set up the blocks and you've pointed the blocks to the library, when you go up to the design library, you should have set up the blocks in the library so that you can come straight to them. There's a balloon mark that I've added which allows me to attach a balloon which picks up the mark in the section. This is not the mark that we're going to use when we consolidate, but it's a mark and it's not the right mark. Okay, so I'm just copying and pasting it. If I can copy and paste, there we go, and likewise here, and likewise there. Now you can put notes on this drawing by putting notes in the sheet template so that all of your welded members have a welding note. So when we go to the drawing side and you do the batch sheet template swap out from the library model template, which is what we've got in place here, we've got a library model sheet template, we can then swap that out. Notes can be added to the drawing to indicate what the mark is and where the mark has to be and its position inside the frame. But at the moment I'm just going to do a basic one so you can see what happens when we consolidate. So we have a frame. I've closed the frame off. The only thing that's open now is the zone assembly with the frame in it. Let's do what we did before by using the copy welded member and select the other sketch segments to attach to, because now we've updated the drawing, we've added some extra information to the drawing, and now we hit the tick. And now this is going to put those welded members back in there again and attach them. However, this time I don't need to go back through each welded member's drawing and update it, because the welded member drawing was copied from this welded member to all the other welded members. And you can see the automatic filing has happened. When I go open up this one, I go to open it up and you'll see that they've all been given a beam 2. If I open the drawing up, you can see the drawing automatically adjusts. All I have to do is a little bit of a tidy up. Save it, get out, close off the welded member. Now I've got my 2 frames. What I can do now is I go over to my consolidation page. And when I consolidate, it will give everything marks. So those marks will come up in the drawings. So if we go to consolidate, we want to update the custom properties. Click on consolidate. And now you can see my sections have all come in. And what it's done, even though that this part here and this part here are in different members, it has given them the same mark because they have the same properties. They're in different members and they've got different file names. However, our consolidation sees them as the same. What we're going to do now is make sure that the marks, by clicking on tools, they get added to the components. So I've clicked on tools and now I'm going to update component mark. So what this is now doing is it's putting the component marks into the custom properties. I close that off. The blue line suggested that they were all good. If I was to select any of these components and click on selecting consolidation, you can see all the sections that reside under that mark. So that section and that section, that section and that section. Which ones are they? Well, let's find out. We can right mouse click and go isolate components, and that's all the sections that are identical to one another. We've set up the mark so that that's the mark, and that mark is now in all of those items. So that when we go to open up the drawings, you'll see that that particular item or that mark annotation that we've added to the drawings have now updated. Do you see how quick that updated? So I can go in and just move these around and tidy them up. Pretty cool how the marks come in. They're just custom properties that have been added to the sections. We'll get into the data and how the data works later. But for now, you know that for marks, if you create a mark, you can add it to your blocks, drag it in and reuse it. And all the mark is it's just a link to the component's custom properties. That's all it is. Because inside that component are custom properties, and one custom property is called mark. This is one way of doing it. You can put marks on. I've seen others. They can actually inscribe the mark into the model so that it shows up as an embossed mark on the section. There are many ways to do this, but all it is just linking it to the custom properties. Now that's it, that's done. You go into this one, and now I open up that drawing. That's done. So you can see now that's automatically updated. All I have to do is just move my marks around to make them look good. Okay, so you see the power and the strength at which the application through its automation has given us. Now I'm going to cover drawings later down the track, but I just wanted to show you how the drawings work with the models when you open them up, and then you can go in and add a bill of materials, and the bill of materials automatically matches the marking that's in the custom properties. I selected update BOM table. This is automated within our document manager, so you don't need to put those in manually. We batch insert them. Okay, so that covers the basics of modeling, how attachment sketches work. Now let's look at top-down driving sketches. Because we created a driving sketch, at the top level we can change any of these dimensions to get the desired result by hitting and double clicking on the dimension and then hitting rebuild. That's what a driving sketch does. So by attaching to this sketch, all of the other welded members have adjusted to attach to it. The drawings that underline, or the drawings to which the models are inside of, have automatically adjusted in their lengths. Control Q, Control S, and if I go in and select any one of these items, whether it be that one or that one, you'll notice that the drawing automatically adjusts. We just go in, do a little bit of a tidy up on the views, and we're in and out fairly quickly. Now those drawings are not complete by any means. We've still got more work to do on them, but we'll cover that later in our drawing tutorial. Okay, so I think we've covered assembly modeling levels, assemblies and mating, attachment sketches, top-down driving approach, relationships. We put in a relationship of equal, parametric behavior, we covered that several times, and driving sketch components and how they're created, and then we've also created envelopes and covered envelopes. So that pretty much concludes this demonstration video. Thank you for your time. If you've got any questions, please send an email to support@cadcraftsman.com, and we'll get back to you with any answers that you need. Thanks for your time. Goodbye.